Hi, I'm Sam Nolan, Sales Engineer with nexAir. Today we're going to talk about automated equipment and how some of these mechanized pieces actually operate and how to best select them. So when you're talking about automated equipment, it's important to remember that there are a lot of different types. What we have here is a 3-axis cutting machine. These pieces of equipment focus on moving back and forth, so your X, your Y, and then of course an up and down. This is your Z. This piece of equipment allows you to produce multiple parts in a row, so you can produce something like this. This nest will produce countless parts, better utilizing all of your material. When you have both an oxy-fuel torch and a plasma, you're able to go all the way up to 6 inches or more of steel, while a plasma, depending on the rating, can go up to 2.5 to 3 inches. So it's important to remember when you're selecting automated equipment that you need to focus on your biggest process, not your smallest. Fume control in automated equipment is also very important. When this is constantly running, you're producing more fumes than any number of weld booths together. So it's important to know how to control it. The table here is a water table. By using a bed of water set about 1 inch below the top of the bottom of the plate, you're able to actually control a lot of your fume output and keep it from getting into the atmosphere. Another option is to use a fume extraction table. Most of these tables have a zone downdraft, whereas the torch moves, it'll actually open up different sections of the table to be able to draw the air down, filter it, and recirculate it into the building. Fume control is very important both for employee safety and due to national regulations. When talking about automated cutting, it's important to remember that the key to these machines is not actually the machine operation, it's really what's in the control panel. Control panel is what gives you the chance to input different parts as well as change your speeds, your settings. These are the brains of these machines. So while machine precision is important, what happens in here is key to what automation is. Automated cutting is a way of ensuring that you get the same part continuously. All automated processes are based on this. However, with automated cutting, you get additional speed as well as precision that you cannot get in a manual cutting operation. So what we have here is a weld-ready part. This came straight from the table, it requires no cleanup, and I can take it to the weld booth and go ahead and get started. The reason for this is that in automated cutting, due mainly to the speeds we're able to get, we use oxygen as our plasma gas instead of air or nitrogen. Both air and nitrogen lead to nitriding in the metal, which is when the metal, because of the heat, actually gets small particles of nitrogen caught in between the atoms. Nitriding means the paint won't stick to it and your welds won't come out too good. So it's really important in automated cutting to ensure that you're using the right gases. Automated cutting is a fairly well understood process. Most large shops use an automated cutting table. Home hobby tables are also growing increasingly common. However, robotics is another story. So let's take a look at the similarities and difference when talking about automated robotics compared to automated cutting. So the first thing to talk about when talking robotics is the robot itself. These are called arms. Each arm will have a varying number of axes. This is a 6-axis system, which is pretty standard. So it rotates along the base, the arm moves up and down here, you have a joint like an elbow, you get another joint here, as well as some rotation. These axes allow the robot to be able to do just about any position that a manual welder is able to do. This position has to relate to what's on your table. This system is a unitized cell, which means it's self-contained. I can pick this up, put it anywhere, hook it up, and we're good to go. But what we need to do is get the fixturing right on our table. So what we have is a simple fixture. It's just to do a fillet weld. And the robot's able to come in, manipulate the torch in the proper position, and weld it out the exact same every time. And that's key to what a robot does. It welds at the same speed as a man. However, it doesn't have to stop. And that's really what people look for in the key to robotics. When talking about robotics, it's important to remember that there are some hesitancies when looking at a system. The primary one being, am I going to put a welder out of work? The answer is no. There is a welder shortage in the US right now, and doing simple parts like this and many other widgets are things that welders can do, but you don't want to have your welder spending all of his time doing a simple part when there are complex parts that require manipulation that a welder can do much better than a simple machine. Another concern is safety, both for employees and part production. You don't want to be making parts and have something go wrong and them get damaged. So what we have are several different options on a system. The first one are emergency stops. These buttons, when pressed, can stop the entire system, whether it's running a program or you're just teaching the robot what to do. They're located on the outside of a unit, whether it's a prefabricated cell or an integrated one, on any of the teach pendants and on the inside of the robot. The other option are these light curtains. What these do are these mark out the area for any part movement, rotation, robotic movement. We'll have a light curtain, so should an operator need to get inside, it will stop the entire system. So if the table's rotating and I reach in, it stops the system before I could even try to touch the table. Then once I'm clear, it'll finish the rotation. So what a cell does, or a robot of any sort, is give the operator a chance to load a part while it's welding. The key benefit to having a robot is to have it constantly working. And so what you'll have is a loader or unloader on one side of the table, on one side of the system, loading a part up while the other one's welding out. So it's important to have your weld times equal your load and unload times. One of the key to robotics is that it has a very tight tolerance when it comes to parts. And so any fixturing needs to accommodate any parts that might be bent or formed in a way that they'd fit up is not always exact. There is programming that can deal with this, however, your basic robot is not able to compensate the way a welder is. So when you're fitting up a part, you always need to be sure everything lines up in the same position every time. Any fixturing needs to be designed so that no matter which operator is loading the parts, they will always be set in the same way. That way, the wire can always hit the weld joint perfectly. So the question comes up, how does this not replace a welder? Well, the important thing is this does not have a brain. It can't think for itself. It doesn't know anything about torch angles or stick out. That's where your welder always is going to come into play, is keeping these things in tolerance. So they need to have a high knowledge of how the arc works, how the weld works, and also be able to operate a pendant. If you can play Xbox, you can operate one of these. So that's not usually the issue, but finding somebody with enough knowledge to be able to make a perfect weld on these systems is where the real issue is. With this brief introduction to automation and robotics, I hope it gives you an idea of how these tools can help you in your shop. It's important to remember, though, that you don't have to look at these things alone. There's companies and lots of us out there who are more than happy to help you spec out a system for your shop and find out what works perfect for you to make the best, most repeatable parts, whether it's cutting, welding, or just choosing a gas.